Got this light fixture, and I like the size of that light fixture. I like the overall design of that light fixture. I don't want to change it out to something, say, like that light fixture or that light fixture. I don't want that. I like that one, and I like that there's 3 lamps in it, and I like that it's right over top of my bench. What's the problem with that light fixture? The problem with this light fixture is, let's have a look inside. There's 2 ballasts. I don't know if that's shining up there very well for you. Let's see if I can get some light on that for you. There we go. Obviously I don't have any light in here because the ballast is burnt out and it's leaking. Can you see that? That stuff, I don't think you want to get that on your hands, and you surely don't want to get it in your mouth. And that ballast right there. So these are both T12 ballasts for a T12 bulb. It's a larger bulb. This would be considered a T8. That's a T12. I'm going to convert this guy over to just 110 line voltage into this LED linear, what do you call it? LED, not linear fluorescent, LED linear lamp. So this is called, this Sylvania, what's it called? A Sylvania, there's a name on it. Ledlescent, I believe it's called. It's a 5000K light. And what else do I know about it? I believe it draws about 18 watts. It's the brightest one you can get. So looking up inside there, I mean, look at all the wires that are moving around. So part of this is, how do we make sense of all of these wires, and how do we hook this whole thing up without a ballast? Well, that's what I'll get into explaining to you. These lights, these linear LEDs, require that you delete the ballast. There are some LEDs, linear LEDs, that you do not need to remove the ballast, because inside the LED lamp itself, it is able to control the voltage, or it has a wide range of voltage that it can accept. Now, I don't know exactly what the output is of a T8 ballast, but it's got to be in the neighborhood of about 600 volts, 500 volts. Normally that would be way, way too much. And it certainly would be too much for that LED, linear LED. So the beauty of this linear LED, I'm going to keep stumbling over that, aren't I? Is that you can use it in a shunted or a non-shunted connector. Normally you have a tombstone connector. It's kind of shaped like a tombstone. You put your 2 points your bulb in, like this, and you click it in. Well, this one has a plunger style. It'll still work in there because the pins are the same length and the same distance apart, pin to pin. So you can go in there. I've taken the time to disassemble this connector, same as that one over there. So, did I say shunted? Yes, I did say shunted. Shunted, I keep messing up. Shuttled and shunted. Anyway, it's shunted. So, non-shunted would mean that those 2 terminals, see those 2, the red and the blue, or over there, are not connected in any fashion together. Shunted means they would be connected, that if I didn't have these 2 wires connected to each other, that I could put my ohm meter on there and there would be no continuity between those 2 points. Does that make sense to you? Yeah, hopefully. So shunted is connected, non-shunted is not connected. You can buy them either way. In some applications, they require that you use a non-shunted or a shunted tombstone or connector. In this case, this bulb will use either. It doesn't matter. The only caveat of using this particular bulb is that you need to gang all the wires together from all. So I would have to take the wire from this one, the wire from this one, this one, this one, this one, this one, tie them all together, and that wire or that bundle of wires would go to neutral or hot, so black or white, and then same with this side. So one side goes to white, let's just say this side goes to white, and this side, which is, sorry, here, goes to black. Understanding? Yeah, you get that? It's not that hard to understand, to be honest with you. So what they're actually telling you to do is to make the fixture or the connector shunted by tying all those wires together. Basically, you're connecting everything together. So although they say it's for shunted or non-shunted, they're telling you that if it is non-shunted, tie it all together and make it shunted. So I don't know why the point of it all, but I'm guessing that it just adds some clarity to it, I guess, instead of confusing it even more. Are you confused? Man, I could get confused just listening to myself talk. Anything else I want to tell you? Oh yeah, I mean these lamps, by the way, say load or line voltage. Say it's line voltage, and neutral. There's an N. So although it seems like they're not polarity neutral, they are in fact polarity neutral, these lamps, because you can take that lamp, flip it around, stick it in the other side. It doesn't matter. So I don't know really why they do that. It would make you think that you have to put neutral on one end and not on the other end. I'll mark it. I mean, I'll mark over on the inside here that one side's neutral and one side's line or load. But apparently it's not necessary. Enough chattering on, huh? What do you need to get this job done? You need a set of strippers. Not the strippers a lot of you guys might like, or you ladies. And some cutters. What else? You might want a tester. You may not need a tester, but if you don't understand electricity and how it flows and these kind of situations, you might want a tester. What else? You want some wire nuts, all sorts of sizes, all sorts of colors. Different sizes are for different gauges of wire, and different sizes of wire nuts, you can gang more than one connection in there. So, you know what I didn't explain, guys, is how these plungers work on here. These just push in. You push the bulb in on one end, and it pushes back against the other end. Basically, there's just springs in there. So, pushes against a backer plate, that plate right there, and that's it. It's just spring loaded. Pretty simple. Kind of an interesting design. I don't think I remember seeing too many of these anymore. Probably all in the garbage. Okay, we got this case all cleared out, all cleaned out. The only thing we have left is our neutral connection and our hot connection, which, by the way, comes through a switch. Some other time we'll explain switches. Anyway, so, by the way, if you're not confident that the power is already off, probably don't touch anything. Matter of fact, have a qualified electrician do your work. Don't take my word for anything. That would be the best. Use this just as an entertainment video. How's that sound? So what do I got here? So I got my two blocks. One from one side, one from the other side. So over here, we have these two, these two, and these two. So the red and the blue from here are shared over to here. And the black and, we'll call them, I don't know, yellow? Let's call them yellow. Black and yellow from that, black and yellow from that. So basically, when you connect these two together, everything together, you now have continuity here and here, here and here, here and here. Matter of fact, the whole thing has continuity all together. And that's what you would have anyway if you were tying it all up to the neutrals. What do I got going on here? Why do I have this like this, this like this? Well, let me explain something to you. Again, entertainment video, okay? So here's the deal. I've seen this many times working on equipment where somebody has come in, done a repair, and ganged up a whole bunch of wires. And then, let's say they take them all together. So there's 6 wires here, plus your connection to the hot. You got 7 wires in. What they'll do is they'll come and grab a wire nut. Let's pretend, for example, they use a wire nut like this. Okay, see how small that is? Now I know that's extreme, but let's say they took that, bundle those all together, try to ram it all in there. Yeah, you'd have some wires connected, some wires not connected, wires hanging out. The whole connection, probably not the best. And what I have seen is wires, when they are not properly connected together, come loose and create a lot of resistance, create a lot of heat. The wires burn up, start a little fire, have a big smoke show, sparks, and best case scenario, nothing happens, obviously. Worst case scenario, your store or your house burns down, and everything in between. So there is a limit to how many wires and whatever that gauge of wire is that you can put into whatever wire nut you have. Obviously here I have a lot of sizes of wire nut. Hey, by the way, if you ever want to know, you buy a wire nut kit, tells you how many wires you can put in to a wire nut, how many size wires. These guys are number 18. This guy that's feeding it is number 14. That's going to be going to the hot. Is there a reason why I have that? No, not specifically. It's just I happen to have that. But a number 14 will easily carry the load of 3 linear LEDs. That's not a problem. Number 12, number 14 could, would have no problem with that. I think total amp draw, I think, is less than 1 for all of these. No, sorry, it must be a little less than 2 amps. So not a problem with that gauge wire. Anyway, bundle up. I bundle up here. What I got? 3. What I got here? 3 together, and the joiner, this little daisy chain piece. So 4 wires. You can put 4 wires together. Let's even just say, for instance, that they're all number 14, which they're not. These are smaller gauge. No problem joining those all up. See how they all fit all nice. Everything's cut correctly. Where are we at? We're done. Well, almost done, huh? Here we go. All your neutrals are tied up. I always tape my wire up inside because when you put the cover on, there's always a chance of pinching a wire and then shorting it out, and then people get scared because there's a big pop and sparks, and nobody likes that in their business. So I tie stuff up, and that's what I do. Anyway, there's all your hots tied together. Of course, I label them. What this does need, I got to grab it. I left the sticker in my truck, but there needs to be a compliance sticker in here stuck somewhere obvious so that if a light does go bad, nobody tries to stick a fluorescent in there. Probably won't work anyway. But so there we go. Let's get the lid back on it, get some bulbs in there. Let's try it out. Here we are in the dark. See anything? Let's give it a shot. Wow. That is nuts. That is amazing. I have no other light on in the shop, and this whole shop is lit up. Wow. I'm amazed. I mean, you'd be so hard pressed to ever find anything that lights better than that. There's 3 in here, obviously. This camera should darken itself a bit to accommodate, but I mean, there you go. LEDs, linear, 5,000K. And yeah, I mean, I would suggest that. Anyone wants to do an upgrade? Man, go the linear LED way. Forget about the fluorescents. They're a little pricey, but I mean, look at the quality of the light. If I got to work at the bench here, I'm not going to lose anything. And you're working on a carburetor or something here at the bench. It's yeah. Anyway, that is it for me. We have something to eat. Enjoy the rest of my day, and listen to the Saskatchewan Rough Rider game, and hope we win and beat those bloody Bombers. Okay, guys, have a good night, and good talking to you. Thanks for hanging out in the garage with me.